can have this. So complex numbers, there are a different type of number that we have sort of a combination of two types of numbers, two different classification of numbers, and um, and we're going to go ahead and combine those two to create our complex numbers here. So today we're defining and computing them. And I did not change this. Oh, goodness gracious. This is supposed to say complex numbers. There you go. Complex numbers. So the definition to complex numbers, since we're now having a new term here, it's numbers that contain one real number and one imaginary number. So take that in consideration. A complex number is a number or numbers in this case that contain one real number and one imaginary numbers. So here on the right side, we have our non-examples. On the left side, we have our examples. Here we have square root of -4. Notice that if we were to take the square root of a negative number, we end up with an imaginary number. So here it's before it's transformed into imaginary number. This would be transformed to 2i, right? Since it's the square root of 4, negative -4, we take that negative or the square root of -1 out, separate the two factors, and take the square root of both numbers. Here on this side, we have 6 plus 8i, 12 minus 6i, and 3i. We'll go ahead and classify each part of the complex number in this case. So over here are non-examples. We have 5. Notice here that it's just a constant. X squared plus 2x plus 1. And 3x plus 12 equals 15. Over here we have a quadratic. Yes, but it's not a complex number. We need a real number and an imaginary number. And in this case, the last one, 3x plus 12 equals 15, it's an equation. We're not looking for equations right now. We just want a number that contains a real number and imaginary number. All right. So with that said, let's go ahead and move on. Let me go ahead and clear this out. Clear. So what are complex numbers? So the definition says it itself. It is a set or a combination of a real number and an imaginary number. Now, do both have to be present at the same time? Not necessarily. But if we have one, then we can go ahead and identify the other. And if we have the other, we can go ahead and identify the, the other. Together, when they're put together, they create that beautiful complex number. So yes, complex numbers are both real numbers and imaginary numbers. And we need both to create that number, that complex number. So let's go ahead and do the anatomy of it. So how do we break it down? How do we define it? So here we have our example. We have 5. Whenever we have 5 by itself, it's a constant. That's what we classify as a real number. And if we add an imaginary number or subtract an imaginary number, here in this case, it's adding 8i. That is what we call our imaginary number, right? So this is the anatomy of it. Let's go ahead and classify now the parts. So here we have example 1a. It says identify the real number and imaginary number. So here we have our complex number 7 plus 5i, and we have to identify the real number. So let me go ahead and get started with first the real number. My real number is, I'm going to go ahead and circle it in red. And it is the number that is our constant, it's irrational. It can be any type of number that is other than imaginary. So in this case, it would be 7. 7 would be our imaginary number. Sorry, no, our real number. Every time my computer restarts, my tablet decides to write slanted. There you go. All right. Come on. There you go. So this is our real number. Now, our imaginary number, I'm going to go ahead and do this one in blue, is obviously what is adding or subtracting and includes our imaginary or that square root of -1 in per se. In this example, it is written as 5i. So this is what we consider our imaginary number. All right. So we've identified the real number. We've identified the imaginary number in this case. Okay, so let's go ahead and move on to example 1b. So here we have another case. We have 6 minus 2i. 6 minus 2i. And let's go ahead and identify the real number. Real number is anything that is rational, irrational, or anything that's real. In this case, non-imaginary. In this case, it's 6. Our imaginary number in this case, it's subtracting 2i. So here, we're going to go ahead and say that our imaginary number is -2i. So imaginary number. All right. Okay, so that was fairly easy. Let's go ahead and move on. Let's go ahead and make it more challenging. Let's see. Can you guys tell me what is, I'll go with the easy part. Can you guys tell me what the imaginary number is here? Darren already said it. He said -8i. So in this case, yes, that is correct. -8i is our imaginary number. All right, so how about our real number? Can you guys identify the real number here? And real number is anything other than imaginary. It can be whole numbers, it can be negative numbers, it can be, Louis says 8. So notice that in our previous case, let me go ahead and put it on or bring it back. We had our constant or our number that was real, and then it was either adding or subtracting 2i or 5i, 12i, whatever the case is. In this case, we only have -8i. If we were to add another number, per se, in this case, let me go ahead and choose my 0. Will we be still able to write -8i? Yes. So what is our real number in this case? Because the number is not written explicitly, our real number in this case is 0. So 0 is the real number. Similarly, if we had just a constant, 0i or anything multiplied by 0 and I would be then our imaginary number. All right, let me go ahead and clear. I think I have one more. Yes, 4i. So go ahead and tell me what's the imaginary number and real number for this one. 4i. 4i and 4i is what? Imaginary, and 0 is our real number in this case. That's right. All right, so we we were able to classify and identify which one is a real number, which one is our imaginary number. All right, so let's go ahead and move on to our next concept. So we were able now to identify real and imaginary, even though one was present, one was not. We were able to know that whenever it's not present, it's 0. Find the sum, difference, and the product. And here we have a binary, two binary numbers or two binary expressions that we have here. We're going to go ahead and just go back a little bit just so we can practice the structure and how to do it when we have variables in this case. And then we're going to go ahead and apply the same structure, the same process to complex numbers. It's very similar, yet a little bit different. But we're going to go ahead and practice in this case. So let's go ahead and find the sum, difference, and the products of these two binary expressions that we have here. So we have 2x plus 5 and x minus 3. So let me go ahead and separate my three working stations. I'm going to go ahead and do the sum, the difference, and the product. Sum, so I have 2x plus 5 plus x minus 3. My mind is thinking, but my words are like not cooperating. All right, so here we're going to go ahead and do the difference. And over here at last, we're doing the product. Okay, so let's go ahead and do the sum first. Notice that there's nothing to be distributed, so we can go ahead and draw parentheses. 2x plus 5, x minus 3. Let's go ahead and combine like terms. We have 2x is 3x. Well, 2x and x is 3x. And lastly, 5 and negative 3, they give the result of 2 plus 2. So here is the simplification of the sum of 2x plus 5 and x minus 3. Now let's go ahead and find the difference. The difference is 2x plus 5 minus x minus 3. Let me go ahead and remind you that because we're subtracting two binary expressions here, binary expressions are expressions with two terms, binary by 2. So we have a subtraction sign here. It means that we have an invisible -1. We do have to distribute that -1 into the second parentheses. So we distribute to our first term and we distribute to our second term. So let's go ahead and rewrite this. We have 2x plus 5. We now have -1 times x is negative x. -1 times -3, positive 3. Once we've done that distribution, we can go ahead and then simplify it by combining like terms and rewriting our expression. So here we have 2x minus x, and 5 plus 3 gives me 8, so plus 8. Now let's go ahead and find the product. So we're going to go ahead and get a quadratic because we have two terms and they're both to the power of 1. So we have 2x plus 5 multiplied by x minus 3. So remember that this will give us, we'll multiply a first term to the next two terms. So you can go ahead and do 2x squared. And 2 times -3 gives me -6x. My next term is 5, so I'll multiply 5 times x plus 5x. And 5 times -3, -15. So from here, we're going to go ahead and combine like terms. 2x squared by itself. We have -6x and 5x. We get -x. And last term that we have -15. So this is going to be just a little recall in regards to adding, subtracting, and finding the multiplication, or in this case, sum, difference, and product of each of the terms that we have here. All right. Where am I going with this? We're going to go ahead and I can do B, but I want to go straight into what do we have our complex numbers here. We're going to similarly apply the same aspect to now our complex numbers. Here we have two sets, right? Our first set of complex numbers, or our first pair, or our first complex number is 5 plus 7i. Our second that we have here is -2 plus 9i. In this case, we're just going to practice on how to do the sum and the difference. The next time we meet, we'll do the multiplication portion of them. So how do we add and subtract complex numbers? How do we find the sum and the difference of a complex number? Let me go ahead and do my two working stations. Remember that I'm going to do just two, because next time we're going to go ahead and do that multiplication portion. And here I go. So I'm going to go ahead and do the sum first. Sum, here is my difference. So sum, I'm going to go ahead and add plus. Difference, we know that we're subtracting. So sum of my two complex numbers, my first complex number is 5 plus 7i plus -2 plus 9i. And notice how, again, the complex number is written. We always write the real number first and then add or subtract the imaginary next. So the real number always goes written first. Imaginary number goes written afterwards if it's added or subtracted. Now, how do we do this? We're going to go ahead and act or think or treat I as if it were a variable, even though we already know its value. We know that the value of I is equal to the square root of -1, right? So whenever we have I, we're going to go ahead and keep those type of terms together and only combine those together. Again, it's like a variable. We're going to treat it like a variable, but it's not a variable. It actually has a value. It's square root of -1. So let's go ahead and do the sum. We're going to go ahead and notice that nothing needs to be distributed. That is directly outside of our parentheses. We're going to go ahead and drop parentheses. 5 plus 7i plus, or in this case, we can go ahead and write -2 and add 9i. So we're going to go ahead and combine like terms. I'm going to combine my real numbers first together. 5 and -2. In this case, it gives me 5 -2 is +3. And next, I'm going to combine my terms with my imaginary numbers with my imaginary numbers. So here in this case, I have 7i and 9i, which gives me 16i in this case. Yes. And that's all we do. So we treat I as if it were a variable. We combine only those imaginary numbers with imaginary numbers and real numbers with real numbers. Now let's go ahead and do the difference. Difference is going to apply very, very similarly. However, we can't forget about that special condition here. So we have 5 plus 7i minus -2 plus 9i. Now we're subtracting the two complex numbers. We have to remember that we have a subtraction sign in between both the numbers. We do have that imaginary one there. It's not imaginary, it's present, we just don't write it. What has to happen? Well, this subtraction sign we do have to distribute and make sure that it's applied to each term inside of the second parentheses, so that we can go ahead and rewrite this. So we have 5 plus 7i. We have -1 times -2 gives us +2. And -1 times +9i, -9i. So now that we've gotten rid of our parentheses, we can go ahead and combine like terms, real numbers with real numbers, imaginary numbers with imaginary numbers. So 5 and 2 gives us 7. And 7i minus 9i gives us negative 2i. Okay, so this is adding and subtracting, finding the sum and the difference between complex numbers. Let me go ahead and save an image of this. And I'm going to go ahead and clear. All right, let me go on to the next example. We have 2 more examples to go, and then you have your exit ticket. Let me go over this one really quickly. And after that, if you guys have any questions, we might go over the last one. If not, I'll go ahead and leave you guys with the exit ticket. So let's go ahead and do this one. We're going to find the sum and the difference very quickly. So our sum we have this time, we have negative 7 plus 3i. And our second complex number, we have negative 3 plus 2i. So negative 7 plus 3i plus negative 3 plus 2i. Let's go ahead and combine like terms. We can go ahead and drop our parentheses. So negative 7 and negative 3. Well, let me go ahead and rewrite it. Negative 7 plus negative 3i plus, well, in this case, it's negative 3. So it's minus 3 plus 2i. Combine like terms. We have negative 7, negative 3, negative 10. In this case, we have 3i and 2i plus 5i. Now let's go ahead and find the difference. Negative 7 plus 3i minus negative 3 plus 2i. Remember that we have our subtraction here. We have that invisible 1. What happens? We do have to distribute. Therefore, let's go ahead and simplify now. Negative 7 plus 3i minus and minus, or negative 1 times negative 3 is positive 3. Negative 1 times positive 2i, negative 2i. Let's go ahead and combine like terms. We have negative 7, positive 3, negative 4. And our complex number or imaginary number, we have 3i and negative 2i plus I in this case. I forgot to put my box around this one. So this is simplifying again, doing this one. I'm going to go ahead and do one more, but I'm going to go ahead and let you guys help me out on this one out. So let's see what you guys get. Okay, clear. All right, last one. 9 minus 2i and negative 1 plus 4i. We're going to go ahead and find the sum and the difference. Let's see, sum. 9 minus 2i plus negative 1 plus 4i. I'll go ahead and let you guys work on this one. Let's see what you guys get. And remember, you guys can unmute yourselves. Jaylene says 8 plus 2i. Agree, disagree? Katya agrees. Luis agrees, and that is correct. So that's the sum of these two complex numbers, 9 minus 2i and negative 1 plus 4i. Let's go ahead and do the difference. 9 minus 2i minus negative 1 plus 4i. Let's see what you guys get for this one. That was quick. So Katya says, "Ooh, I have two of them. I have 10 plus 6i, and I have 10 minus 6i." Louis says minus 6i. Katya. Okay, Katya goes with 10 minus 6i. Let me go ahead and delete this one and bring this one over. All right. So yes, this is correct. 10 minus 6i. Remember, you have to distribute that negative one over and combine like terms. That I plus 1 and minus 4i. So you get your 10 and you get your negative 6i. All right. All right. Any questions on this? And this is just multiplying. No, not multiplying. Sorry. Finding the sum and the difference of complex numbers. Next time we meet, we'll do the multiplication. That again will take another lesson on itself. So I want to focus on that by itself and give you guys more time to practice on just the sum and the differences for right now, since you've just been introduced to complex numbers. Any questions? No, they say Chris. Okay. All right. Thank you very much, guys. You have your exit tickets. Let me go ahead and present it to you really quickly. You have identify the real number and imaginary number. And the second question is find the sum and the difference of the complex number. You have 2 plus 3i, 6 minus 5i. So go ahead and submit that on Canvas. We don't have a Nearpod slide for that. So I'll go ahead and continue to use this as a pattern for you guys to submit any type of notes or exit tickets in regards to class participation. Okay. All right. So homework is posted. Lesson is posted. You guys have access to that. Let me know if you guys need to meet for any tutoring and or have any other questions. Okay. So I'll see you guys on Friday. Bye, Chris.